Yeah, hi guys. Let us start the day by putting up this question: direction of electricity. Do we know the direction of the electricity? So, for this, let us do a quick recap of the DC current which we studied in our previous video. So, what we studied? We studied that this is a battery, yeah, and there is a resistor, and this is circuit like this, okay, and this is positive terminal of the battery and negative terminal of the battery. This I am representing corresponding to, this is symbolic representation, this I am representing corresponding to the negative terminal of the pencil cell or the battery, yeah, or the and the positive terminal of the uh, cell, okay. You can say this corresponds to this and this corresponds to this. So going forward we will not draw battery like this, okay. Basically it is a matter of displaying voltage, okay, voltage, or you can say potential difference. These things we will discuss going forward, no worry. Let me write this word else we can forget. I will try to cover this as well. Potential difference, yeah. This is something which we're gonna park for some time and then we'll revisit, okay. So going forward we will represent battery using this way. You can say as simple as that. The bigger line shows positive terminal and the smaller line shows negative terminal. It is as simple as that. So what we have studied in our previous chapter, we studied that suppose this is a pencil battery, okay. It is the negative terminal of the pencil battery and it is positive terminal of the pencil battery, and if you connect with a bulb, yeah, with a bulb, this is the bulb, yeah, and of course it is having some filament, and yes, yeah, we studied that electrons will keep on flowing from its negative terminal, from the negative terminal of the pencil cell to the positive terminal of the pencil cell, yeah. Meanwhile it'll make the electric bulb glowing, okay. So electric bulb is glowing, that means pencil cell or the battery which is charged, it is charged, okay. These things we have already discussed in our previous chapter, okay. So what we saw there, we saw that electrons flows from the negative terminals to the towards the positive terminals, because here number of electrons are extra and here electrons are lesser in number. Just let me write here extra electrons, you can say extra electrons, and here is lesser. We should use deficiency of electrons, actually that is a better term. Deficiency means that is a lacking of something, okay. Deficiency of electrons. Here electrons on this terminal, electrons are lacking, and here surplus of electrons. So electron will keep on flowing from negative to the positive terminal till the time number of electrons become equal on both the terminal, yeah. And after that there will be no potential difference, okay, or you can say no gradient, okay. After some time, let me write it. After some time, no gradient, no, or you can say no gradient. What we mean by no gradient? Where no potential difference, you can say in that way, okay. No potential difference, no potential difference. So I think we have covered. So for now we have to know only this much. What we mean by potential difference, you can say this, the two terminals of a battery, okay. So now let us move further, okay. So here what this represents, this represents the positive terminal of the cell and negative terminal of the cell or battery, whatever you say, okay. So what we know that electrons will flow from this terminal to this terminal, right? Now the question is, what is the direction of the electricity? Okay, direction of the electricity. Now direction of, let me write it down. Direction of electricity, okay, direction of electricity is always opposite to the direction of the flow of electrons. Always opposite to the direction of the flow of electron. This is very important. Direction of the flow of electrons. Okay, this is a very important thing which we have to, this is a keyword, this is something which we have to remember all the time. Okay, so going forward, what we will say, this is the movement of the electron. So if I ask you in which direction electricity is flowing, straight away you have to say in this direction. This is the flow of the electricity, this is the direction of the flow of electricity. Electricity will flow from this direction. Now the question is, why it happened? Yeah, there is reason. Because we have already learned that electricity is a natural phenomenon. It is not something which human beings have invented. Okay, it is a natural phenomenon. So it is us who discovered it. Okay, and initially when we witnessed, when we tried to understand this lightning and thundering event, okay, in the sky, between the clouds, the scientific community said, okay, something flows, that something, they said, charge flows. Okay, at that time they didn't had a clear meaning of charge, they simply said it is a flow of charge which we are witnessing in the form of lightning. Okay, I repeat, it is a flow of charge which we are witnessing in the form of lightning. So this was the reasoning of the scientific community, okay, when they started exploring around electricity in the year, I think, 15th or 16th century. So at that time it was, so they said that this electricity will flow from positive to the negative terminal, okay, from higher potential to the lower potential. Everything has a tendency, natural tendency, to flow from higher level to the lower level, just to equalize it. Yeah, we have already seen in our previous video that it is a tank which is kept on your house. This is your house. We used to keep the tank, water tank, uh, on the top of your house, okay, one or two floors up to your house. Why? So that natural, so that water can naturally flow down. Yeah, you don't require to put in any kind of power, external power. Okay, so this is what we do. So this is a natural phenomenon, you can say. Everything has a tendency to flow from higher potential to lower potential. Yeah, so let us again say, so what is the old definition? I'm just going to the old definition. Says, or you can say it is a preliminary definition, basically. Okay, um, yeah, let me redefine it. Yeah. Preliminary definition says electricity is caused due to flow of charge. Okay, this is something which we have already discussed in our videos. Okay, and what is the modern definition? Says, modern definition says electricity is caused due to the flow of electrons. See, this is same. Okay, this flow of electrons, let me write it using, electricity is caused due to the flow of electrons. So now the question is, what is charge and what is electron? Is there a correlation between them? I can say yes. So all charge which we are talking about, be it positive or negative, that is basically due to the movement of electrons. We have already discussed in our previous chapter that, so this is a nucleus, okay, which is positively charged. Electrons reside outside nucleus. Yeah, electrons reside outside nucleus, and protons reside intact inside the nucleus. So protons cannot move out of an atom. It is electrons which are free to move here and there. Yeah. So what we mean by charge now? So charge is the event of, like, the, you can say, the phenomenon of charging arise due to the movement of electrons. Okay. So charge, for now, you can consider charge and electrons almost same. Okay, you can consider it same for a while. At your level you can consider same, though we know that charge is of two types, plus and minus. But why charge created? It is only because of the movement of electrons, nothing else. Protons cannot move because it is tightly packed. Okay, so now the scientific community had a challenge to accommodate both the definition, the preliminary definition and the modern definition. Yeah, because this is something which we cannot discard. Yeah, because this is the building blocks of our understanding, okay, towards electricity. So we agreed that, okay, flow of charge, so this is direction of electricity is always opposite to the direction of the electrons. So if this is the direction of the electrons, okay, so what will be the direction of the flow of electric current? So straight away you can say electric current flows in this direction. Okay, this is the direction of electric current. Yeah. So going forward you will come across a term called conventional current. Conventional current. Okay, conventional current is nothing but same as DC current. You can say it's another name. Okay, let me write it as conventional current. You can simply say it is simple DC current. At your level you can say yes, it is simple DC current. And one more thing I would like to uh, add on here, though it is something which we have already discussed, I just wanted to reiterate. All this direction of the flow of electrons, and we got to know the direction of the flow of electric current, okay, only after discovering the subatomic particles. That is, I'm talking about electrons. Yeah, when when scientists took an attempt to explore around the phenomenon of electricity, they had no idea about subatomic particles. Even they were not aware of electrons, protons and neutrons. Okay, so at that time there was no such concepts. So the current, so this is what they said, conventional current. And later on, with the discovery of electrons, we found that the event of charging takes place because of the flow of electrons. Yeah, so it's a kind of giving honor to their work. That's why we have adopted this particular two things. Both these things point to the electric current. Yeah, DC electric current or conventional current. Okay, you can say, if someone asks you what is the modern definition of DC current, you can say it flows in the direction of the flow of electrons. And what is the definition of conventional current? You can say, you need to say it flows opposite to the direction of the electrons. But anyway, whatever be the case, going forward we will say that if this is a battery, yeah, so suppose this is this is a resistor, okay. So current will always flow from its positive terminal to its negative terminal, yeah. Now let us forget the flow of electrons. We will not talk about the flow of electrons. Yeah, I repeat, going forward we will not talk about the flow of electrons. Yeah, we will simply talk about flow of electricity. That means we are going to talk about like if you are talking about a DC current, that means we are talking about conventional current. Simple conventional current. This is a keyword, is a key takeaway, you can say. Conventional current, this is simply same as DC current, okay, which flows from positive terminal of the battery to the negative terminal of the battery. Yeah, I'm going back to the types of electric current. Yeah, so I think we are done with DC type of electric current, okay, and we started our journey uh, with this, that electric current is of two types, DC and AC, okay. DC is direct current, which we already discussed. We are done with that. At your level you can say it is same as conventional current, and don't confused, okay. So what is alternating current? This is bit, let me alternating current. So let us try to understand it, okay. See, alternating current is I would say is complicated things. I have tried my best to extract the things which can be understood at your level, okay. So what we have studied about uh, direct current, we said this DC is a like it's a flow of electrons in one direction, okay, or you can say flow of charge in one direction, okay. Flow of charge in one direction, yeah. This is DC current, which we have already studied. This is positive terminal and negative terminal of the battery, and a wire is connected, okay. So current will flow in this direction. This is the flow of the, and we denote current with the letter I. We will discuss about current later, yeah, in mathematical terms, how it is related with the charge. Anyway, so what is AC? AC, as the name suggests, alternating current, means its direction keeps on fluctuating. I would say its direction, the current is half is positive. Let me write it. The current is fluctuates. Fluctuates, I think you understand. Fluctuates means is something like this. Means it is on off kind of thing. You can understand that way. Okay, the current fluctuates between plus and minus. Okay, plus and minus, these are again a vague term I have used. Okay, so this is just for you to understand. That means that means direction reverses after each half time. That means the direction of AC current, okay, AC current reverses, yeah, reverses after each half time. Yeah, it is good. To each half time. So don't worry guys, this appears to be complicated, I know. I'll try my best to make you understand. So what all I have written, it fluctuates between plus and minus. Okay, this I have written intentionally. This is not the right way of explaining AC current. So that means, yeah, that's what I have written. That means the direction of the AC current, the direction of the AC current reverses. This is a keyword, you can say. This is a keyword. The direction of the AC current reverses after each half time period. After each half time. Okay. So what we mean by half time? Let us start by drawing a graph. This is interesting. Okay, on x-axis let's gonna represent time. This represents time. Okay, t means time. Okay, and v represents current, as I said, with the letter I. Okay, so what will happen, it will keep on fluctuating like this way. I think you guys must have seen such kind of picture. So, and we must know that, see, this is the positive side of y-axis, upside, considering this is origin. Okay, and this is the downside of y-axis. This is negative, we know, and this is positive. This represents the electric current, this AC current. Okay, so that's why I said the current fluctuates between positive and negative, between plus and minus. See, in this time period this was in plus zone, and after that it shifted to minus zone, and after that it went to 0, and then again move to plus. So this kind of things keeps on happening. Okay, so actually what is time? So with time, actually, let me write, let me tell you what I mean to say here. Time period. Time period is a standard term. Okay, let me define it, what we mean by time period. Okay, so this is a question which must come to your mind. So time period, you can say, the duration in which one cycle gets complete. Yeah, the duration in which one cycle gets complete. This is the thing. Okay, what we mean by one cycle, let me tell you. Consider this. This is the peak. Okay, after how much time the position, like the current will be at the same position. After this much time, you can say, after spending this much time, position will be restored, or position will be same. Yeah, position will be restored, it is better. Yeah, position will be restored. Position of what? Position of any time on the curve, but mostly we consider, like, do we know, just let us park this for a while, we will come here. Okay, let me tell you something. We must have studied, if you have studied wave. Okay, let me tell you, wave appears like this. Yeah, it consists of trough and crests. Okay, this is the structure of wave. A wave appears in physics, the wave which we study in physics, yeah, appears like this. We denote it like this. Yeah, so you can clearly see it has two points. Yeah, what we should say, two maximum points. Okay, or two maximum height. I know things might be bouncing over your head, just pay attention. With the passage of time you'll be able to understand these things. They are not rocket science here. So this part is called trough. Okay, we call it trough. And this maximum height in the positive direction is called crest. Okay, so I repeat, this is the positive side of y-axis and this is negative side of y-axis. Okay, so wave which we study appears like this. Yeah, it has maximum height in both the direction of y-axis. The maximum height in the positive direction, in the positive upper side, the maximum height in the upper side is called crest, and the maximum height, yeah, in the negative direction is called trough. So crest and trough, this is what happens. Yeah, so now let us come back to here. So this AC current also appears like same. We called it sinusoidal wave. Sinusoidal wave. Or in short, you can say it's sine wave. Sine wave. Yeah. We'll not go into the details of sine wave, okay, because that involves lots of high level mathematics, yeah, which is not at your level, and things will go out of your mind. Anyway, so we were discussing what is time period. I said the duration in which one cycle gets complete. So what we mean by one cycle? One cycle means, you know, down start from this time period, because this corresponds to maximum height, this maximum height. Okay, so I'm saying after how much time the position of the wave, yeah, gets restored, means after how much time the same height, the same maximum height is reached. It is as simple as that. Okay, this is called one time period. Okay, this is called one time period. So you can take any thing, so this will be represented as one time period. So if we extend this wave, yeah, and we go like this, I said you can start from any point. Just make sure that you reach to that particular point, and say and see after how much time you reach to that particular point. Suppose next time, suppose let us start from this point. After how much time we are able to reach the same height, same point. Same point is here. You can say after spending this much time, so this becomes one time period. So we represent time period with the letter capital T. This is standard practice. So wherever you see capital T, just be conscious. This is not normal time. We are talking about some time period. So T represents time period. Wherever you see capital T, that means you need to be cautious about it. Okay, it's not a rocket science, just that is as simple as that. Okay, so what you observed, that the value of the current keeps on fluctuating. Okay, sometimes it goes in the plus side, and sometimes, like exactly half of the time, it goes to the negative side. This is what I wrote down here. The direction of AC current reverses means it changes. Okay, suppose you are going in this way, in this direction, you reversed, that means you just took 180-degree turn, just completely opposite. The direction of AC current reverses after each half time. See, the direction of AC current reverses after each half time. So if I ask you to find out half time, means if I ask you to find out T by 2, will you be able to find out? Yeah, probably yes, you should be. So where is half time? This is half time. Okay. So what is a half of this? This, sorry, not this is a half time. This is one time period. So what is half time period? It is as simple as that. This is simple geometry. Half time period means you can say this is the half time period. This will give you half time period. Yeah. Capital T by 2. Okay. This is, so what, and the remaining, this is again half. Okay. Half plus half makes 1. Half T, half T, half T plus half T makes 1T. As simple as that. This is what I have tried to written. Fantastic. So what do you see? After each half time, the direction of the current reverses. Just observe it. This is what is happening. So you can say, so just keep your knowledge about alternating current up to this level. Let me add one more thing here. How do we represent a conventional voltage or conventional potential difference? We studied potential difference here. This is nothing but this is potential difference. This is voltage. Whatever you see, it has different name. Gradient. We call it potential difference basically. Okay. Fine. So I'll keep it referring to this. Okay, because this is very important for us to understand. So how do we represent potential difference in case of DC and AC? This is very simple, and after that we will wind up. This is DC. Okay, we represent potential difference in this way. This is big one means plus and this is minus. Suppose this is connected to an electric bulb. Okay, the direction of the flow of the electricity will take place from positive terminal of the battery to the negative terminal, right? Fine. And the electric bulb is glowing. Fantastic. This is the case of DC. In case of AC, how to represent this potential difference? Let me write it. This represents potential difference. Okay. How to represent potential difference in case of alternating current? It is very simple. We represent in this way. And electric bulb, it is as simple as that. So see here, the symbol is like this. That represents an AC current, because we know it's a sinusoidal wave. AC current is a sinusoidal wave. This is what we have studied. Yeah, it is a sinusoidal wave, sine wave, which keeps on fluctuating. Okay, so I repeat, let us take a quick recap around AC current. The current fluctuates between plus and minus. That means the direction of AC current reverses after each half time. And how about the DC current? The direction doesn't fluctuate. Flow of charge in one direction. So that is one of the biggest difference between DC and AC current. So let us write down the difference between DC and AC current. What are the differences? What can you say? In case of DC, direction of current, okay, remains in one direction, and the direction of AC current is the direction of current reverses after each half time. I think for now at your level um, you should you should keep only this much thing, okay, in your mind. I think that is more than enough. Be cautious about alternating current. Yeah, the direction of current reverses after each half time. We have discussed about time period. So after each time, after each half time means t by 2, capital T by 2. Yeah, and in case of DC current, direction of current remains in one direction. Now the next thing which we're going to talk about is what is switch. We must have observed in our houses that we have switch for bulb, we have switch for tube light, we have switch for um, fan. Yeah, we have switch for television. Yeah, so what is switch? Let us try to understand it. This is a conventional current. Yeah, I am going to take. And one more thing I wanted to add on here. So going forward, I am not going to glow this kind of bulb and all. Yeah, basically what a bulb contains a filament which offers resistance, okay, and it is called resistor, you can say. Yeah, it is called resistor. We represent resistor in this way. This represents a resistor. We will try to understand how an electric bulb glows, okay, how an electric bulb glows, but not now, later on. Okay, for now you can remember that electric bulb contains a resistor. It is as simple as that. So this is what I have drawn here. Okay, this is a case of conventional current. This is the positive terminal of the battery, and this is negative terminal of the battery. So what will the direction of the flow of electric current? It will flow from positive terminals to negative terminal, means this way. Yeah. So what is switch? This is a circuit. Before I proceed further, what is this called? This entire thing, we call it circuit. Okay, this is a keyword actually. So let me highlight it. This is circuit. This represents a circuit. So now implement switch. Implement a switch. Basically what I am trying to say is that let us add a switch, a provision of switch in this circuit. So how it will appear then? It will appear this way. This is positive terminal, this is negative terminal of the battery. Yeah, there is a resistor, okay, and this is switch. This is switch. This is called switch. You can think switch something like this. Okay, now in this case, just observe it. I have kept these 2 points away from each other. They are not connected. Yeah, so that means let me write it. Since the two ends of the switch is not connected. Okay, so current will not flow, hence current will not flow. Current means electric current. Yeah, current will not flow. This is again you need to understand. So now the thing is, when current flows in a circuit, in order to flow current in a circuit, it is essential that circuit is intact, means there is no breakage. But see here, there is clear cut breakage. The two ends of switch are not connected, not closed. Yeah, you can say this represents an open circuit. Okay, we call it open circuit. Circuit is open, so current will not flow. Open circuit, that means current will not flow. It is as simple as that. Open circuit, current will not flow. So let us make a circuit in which the in which all in which the two ends of the switch is closed, meets each other. Yeah, this is again a resistor. So now just let me draw this once again. There is a purpose. Switch is open. Yeah, this is called switch. It makes the circuit open. Open circuit. Current flows. No current. Close the circuit. Close the switch. Sorry. Close the switch. What happens after, what do we mean by closing the switch? Yeah, closing the switch means connecting both the ends of the switch. This is both the ends of the switch. Now they are well connected. What we call it? We call it closed circuit. Closed circuit. Now how about current? Current will flow or not? It will flow. So current will flow. Yes. In case of open circuit, current will not flow. In case of closed circuit, current will flow. So this is the work of switch. What happens when you switch off your tube light? That means you are making this kind of condition, this kind of situation, or whatever you say. Yeah, means you make the circuit open, and after that the tube light stops. When you switch on the tube light, the circuit becomes complete. That means it becomes closed again. So closed circuit means it is a complete circuit. Yes, you can say it is. After closing the circuit, it becomes a complete circuit. If the circuit is complete, only then current will flow. In which direction? Again, This is the positive end, this is the negative end of the battery, so it will flow from this end, this way. Yeah, it is as simple as that. So this is the work of switch. Now the next question which we will take is how current flows through human body. Have you come across a situation wherein you or someone else touch a live wire, okay, or by mistake your finger got touched with a plug, yeah, something like this, what I'm saying. This is a human body, this is a pictorial representation, okay, this is human body, okay, and this is wire carrying current, wire carrying current. This is a wire, this is a piece of wire which is carrying current. If you go and touch this wire, okay, and your feet, means considering that you are barefooted, it is essential that you are barefooted, just keep in mind, means you are not wearing any slipper or shoes, okay, your feet are directly in touch with the ground, okay, we represent ground this way in electricity, okay. What will happen, you will get a kind of a shock, you will get a shock, electric shock. Shock means electric current flows through the human body. Hmm? There can be cases wherein a person dies, yeah, because of that. We should not touch any kind of wire which is carrying current, being barefooted. We should not have a habit of touching any kind of live wire. Live wire means a wire, let me write it. Live wire. Live wire means a wire which is carrying current. Yeah, we should not touch a live wire. It is as simple as that. This is a standard practice we should adopt. Otherwise, it will cost our life. Let us see how current flows through human body. So before I come to this, we need to understand one concept which is called potential difference. I think we discussed for some time what is potential difference. Potential difference is something this is potential difference, this causes the potential difference, this end is positive and this end is minus, yeah. Basically if you take a pencil battery, yeah, you will see some voltage is written over there, 5 volt, 2 volt, 3 volt. Let us take an example, it has 10 volt, 10 V battery. 10 V means 10 volt, 10 volt, okay, battery. So what we mean by 10 volt, let me tell you what we mean by 10 volt. It means this is 10 volt plus 10 volt means plus 10 volt, it is as simple as that, and this negative terminal is 0, it is 0 volt, absolutely it is 0 volt. The circuit is closed, yeah, so current flows. Right, we know this much. It is very essential for us to understand potential difference. So this is potential difference, this is potential difference, the same concept. Here I have explained one extra thing, plus and minus, what they mean actually. I have taken an example of a battery or a cell, yeah, which offers a potential difference of 10 volt. That means the positive terminal of the battery has a potential of 10 volt, and the negative terminal of the battery will always have 0 volt. Just take a note. The negative terminal of the battery will always um, has will always have 0 volt. Okay, this is this is the way we have built our understanding. Okay, so now come to this. This is a wire carrying current. Of course, it will have certain voltage. Yeah, let us say it is 220 volt. Means current is flowing in this wire. The voltage is 220 volt. Okay, or I'll make you just make you to understand in a pretty easier way. Let me draw another picture. Suppose this is 220 volt. Now you know what we mean by 220 volt. That means this end is 220 volt and this is 0 volt. Yeah, it was supposed to flow through this resistor. Okay, fine, it was flowing through that. Perfectly fine. The circuit is closed. Yeah, current is flowing fine, fantastic. Now you suddenly came in and touched this wire. You are barefooted. Means your feet are in touch with the ground. The ground has a potential of 0. Just remember that. The ground has a potential of 0. This ground potential is 0 volt. This is a practice which we adopt. Okay, or you can say this is ground potential is 0. Okay, so this corresponds to this. You can imagine in that way. This corresponds to the negative terminal of the battery. Ground corresponds to the negative terminal of the battery. I repeat, ground corresponds to the negative terminal of the battery. Okay, because we know negative terminal of the battery means the potential of the negative terminal is 0 volt, and here the potential of the ground is also 0 volt. So you can consider this analogy. Yeah, so now the current always flows from positive terminal to the 0 volt, right, to the negative terminal. And you have touched, the current was flowing and you touched this wire. You are barefooted, you are directly in touch, your feet are directly in touch with the ground. So what will happen? The current will not flow in this direction. It will not flow in this direction. Okay, it will stop flowing through the wire. Instead it will go through your body, or let us say it will not flow through. No, we should not say this, actually, sorry for that. It will continue to flow, but some amount of current, okay, some amount of current, sorry for creating confusion. So some amount of current, okay, will get deviated through your body. It will enter your body. We know our body are made up of cells. Okay, so it'll traverse the journey by moving through cells of the human body. Let me write it. Cells of the human body. Yeah, it will traverse through the cells of the human body and will reach the ground. So what happens? Current flows through your body. Current flows through your body and reach the ground. And this is how we used to get a shock. So we should not touch any kind of wire which carries current.